Hello students, this is your Shailesh sir, and today we are going to start refraction of light. Okay, so what is refraction of light? As we see that when light travels from one transparent medium to another transparent medium, then it gets deviated from its original path. Okay, so this phenomena of bending of light from its original path is called refraction of light. Okay, so if light travels from one medium to another medium, then it bends towards the normal or away from the normal depending on the medium. Okay, so what is rarer medium or what is denser medium? Rarer or denser medium can be defined as that medium which have greater density is called a denser medium, and comparatively that medium which have less density is called rarer medium. Okay, suppose we take air, water and glass. Okay, so if we compare these two mediums, air and water, then we can say that the air is rarer medium and water is denser medium. Why? Because the density of air is less than the density of water. Okay, and if we take these two mediums, water and glass, then we can say that the water is rarer medium and glass is denser medium, because the density of glass is greater than the density of water. So we can say that glass is denser medium and water is rarer medium. Okay, so if light travels from rarer medium to denser medium, then light bends towards the normal. Okay, and if light ray travels from denser medium to rarer medium, then it bend away from the normal. So for this condition, angle I is greater than angle R. Angle of incidence is greater than angle of refraction, because I is angle of incidence and R is the angle of refraction, and this is incident ray, this is refracted ray, and this is normal. So if light travels from rarer medium to denser medium, it gets deviated or it bends towards the normal. So angle I is greater than angle R. Okay. Now for this condition, if light ray travels from denser medium to rarer medium, then it bends away from the normal. So angle I is less than angle R for this condition. Okay. So this is the refraction of light. Okay. Now there are two rules of refraction of light. Okay. So first rule says that the ratio of sine of angle of incidence to the sine of angle of refraction is always constant, and this rule is also called Snell's law. Okay, so we can say that the ratio of sine of angle of incidence to the sine of angle of refraction is always constant, and that constant can be represented as 1 and 2, or we can say only n. Okay, so what is 1 and 2? 1 and 2 is the refractive index of the medium. Refractive index of the medium 2 with respect to 1. With respect to 1. Okay. So this is the first rule of refraction of light. Okay, and second rule says that the incident ray, refracted ray and normal at the point of incidence, these all lie in the same plane. Okay, I am repeating, incident ray, refracted ray and normal at the point of incidence, these all lie in the same plane. This is the second rule of the refraction. Okay, now we will discuss the refractive index. What is refractive index? So refractive index is also called absolute refractive index. Okay, so the refractive index is defined as the ratio of speed of light in vacuum to the speed of light in any medium is called refractive index of that medium. Okay, so refractive index can be represented by n and it is the ratio of speed of light in vacuum, or we can say speed of light in air divided by the speed of light in medium. Speed of light in medium. Okay, so speed of light in air or vacuum is represented by c, and speed of light in medium is v. So we can say n equals to c upon v. This is the formula for refractive index. Okay, and refractive index is also called absolute refractive index. Why? Because the refractive index of any medium with respect to vacuum, because we have considered that first medium is vacuum and light travels from vacuum to a medium. Suppose this is a interface and this is a vacuum, and this medium is another, suppose water. If light travels from vacuum to water, or we can say air to water, vacuum or air consider करें, then vacuum or air, light travels from vacuum to water, then it gets bent towards the normal. Okay, so here we can say that the refractive index is the ratio of speed of light in the first medium to the speed of light in second medium. Okay, so it is the ratio of speed of light in vacuum to the speed of light in water. We will define relative refractive index. Relative refractive index. So what is relative refractive index? The refractive index of any medium with respect to any other medium is called relative refractive index, and absolute refractive index, the refractive index of any medium with respect to vacuum, is called absolute refractive index. This is the difference between refractive index and relative refractive index. Okay, so in refractive index we say that the refractive index of any medium with respect to vacuum, and relative refractive index we say that the refractive index of any medium with respect to any other medium is called relative refractive index. So here if we consider this is a medium 1 and this is medium 2. So the relative refractive index can be represented at 1 and 2, because light travels from one medium to second medium. Then we will write the refractive index of 2 with respect to 1 and 2. Okay, so 1 and 2 can be represented as V1 upon V2. Means if the speed of light in medium 1 is V1 and speed of light in medium 2 is V2, then the ratio of speed of light in medium first to the speed of light in medium second is called relative refractive index. Okay, so 1 and 2 can be represented as V1 upon V2, and we know that the speed of light or speed of any wave equals to nu into lambda, where nu is frequency and lambda is the wavelength. Okay, so for first medium we can say V1 equals to nu lambda 1, and for second medium we can say V2 equals to nu lambda 2. Here nu is constant because speed and wavelength, these quantities will change when light travels from one medium to second medium, but frequency will be always constant whether light travels from any one medium to any other medium. Okay, so frequency is always constant. So we can write nu lambda 1 upon nu lambda 2. So nu will be cancelled, and 1 and 2 we can write 1 and 2 equals to V1 upon V2 equals to lambda 1 upon lambda 2. Okay, so this is the formula for refractive index, or we can say relative refractive index. And 1 and 2 this can be also written as N2 upon N1. Why? Because 1 N2 is the refractive index of second medium with respect to first, but here we will write N2. So N2 is the absolute refractive index of second medium and N1 is the absolute refractive index of first medium. Okay. So here N2 and N1, these are the absolute refractive indexes, and 1 and 2, this is the relative refractive index of second medium. Clear? Now we will discuss the principle of reversibility. Okay. So according to this principle, if the final path of a ray of light after suffered several reflections and reflections is reversed, then it retraces its path exactly. Means if a light is traveling from one medium to another medium and suffers many refractions and many reflections, then if we reverse, or we can say if we place a plane mirror perpendicular to the incident light, then it retraces its original path. Okay. So we can say this is a incident light and this is a refracted light, and after reflection this will retrace its original path. This phenomena is called reversibility of light. Okay. Now we will apply the Snell's law in this refraction. So by the Snell's law, and I had discussed it in the refraction of light, Snell's law says that the ratio of sine of angle of incidence to the sine of angle of refraction is always constant. So we see that sine I upon sine R, because the angle of incidence is I and angle of refraction is R. So sine I upon sine R equals to 1 and 2. Okay, this is equation 1. Now after a reflection, this light ray gets refracted in same path. So for reflected light or for reflected ray, the angle of incidence is R and angle of refraction is I. Okay, because it moving from medium 2 to medium 1. So this will be sine R upon sine I equals to, we can say 2n1. Okay, 2n1. Why? Because this reflected ray travels from medium 2 to medium 1. So we will write 2n1. Okay, and for incident light, that will be travels from medium 1 to medium 2, then we will write 1 and 2. Okay, so here it is clear that the refractive index 1 and 2 means light travels from one medium to second medium, and 2 and 1 means light travels from medium 2 to medium 1. Okay, so this is the second equation. Now multiplying equation 1 and 2, from equation 1 and 2, we will write sine I upon sine R into sine R upon sine I equals to 1 and 2 into 2 and 1. Okay, so this will be cancelled and the value of 1 and 2 into 2 and 1 equals to 1. So we can write 2 and 1 equals to 1 upon 1 and 2. So principle of reversibility says that the refractive index of second medium with respect to first is the reciprocal of the refractive index of first medium with respect to second. Okay, so here 2 and 1 is the refractive index of first medium with respect to second, and 1 and 2 is the refractive index of second medium with respect to first. So here we will write 1 and 2 is the refractive index of medium 1, refractive index of medium 2 with respect to medium 1. Okay, and 2 and 1 is the refractive index of medium 1 with respect to medium 2. Okay, this is the principle of reversibility. So here, if we consider rarer medium is air and denser medium is glass. So medium 1 is air and medium 2 is glass. So we can write 2 and 1. We will write 2 and 1 as GNA. GNA means the refractive index of air with respect to glass. Okay, so GNA equals to 1 upon A and G. Okay, so A and G is the refractive index of glass with respect to air. So here we will write it in this form. Okay, now if we consider next condition, if we consider first medium is water, okay, and second medium is glass, then for this condition we will write 2 and 1. So 2 and 1 means GNW. GNW, this is the refractive index of water with respect to glass. This will be equal to 1 upon WNG, and WNG says that refractive index of glass with respect to water. Okay, so we can write it in this form: WNG equals to 1 upon GNW, and WNG is also written as A and G upon A and W. This is the most important formula. WNG equals to A and G upon A and W. Why? Because A and G is the refractive index, or we can say absolute refractive index of glass, and A and W, this is the absolute refractive index of water. Okay, so the relative refractive index is the ratio of absolute refractive index of second medium with respect to the absolute refractive index of first medium. So here we see that the refractive index of glass with respect to water is the ratio of absolute refractive index of glass to the absolute refractive index of water. Okay, now we will discuss the refraction through rectangular glass slab. Okay, so we consider this is a rectangular glass slab which is placed in air. Okay, and this is a incident light or incident ray which makes angle I with the normal. So this is angle of incidence, and after refraction, if this light travels from air to glass, then it bends towards the normal. Then this is the angle of refraction, and this refracted light ray gets refraction and bends away from the normal, because this light ray travels from glass to air. Okay, so this is angle of R and this is angle of emergence, that is E, and these are for this surface AB, this is angle of incidence and this is angle of refraction, and surface CD, this is angle of incidence and this is angle of refraction. Now we will apply Snell's law. So by Snell's law we apply it sin I for surface AB, sin I upon sin R equals to the refractive index of glass with respect to air. We will write A N G because light ray travels from air to glass. So we will write A N G. Okay, this is equation first. Now this is for surface AB. Now we will apply the Snell's law for surface CD. So for surface CD we will apply Snell's law. So here the angle of incidence is R and angle of refraction is E. Angle of incidence R and angle of refraction is E, and we will write this is glass and this is air. So light travels from glass to air. So we will write GNA. Okay. Now this is equation second. On multiplying both equations, equation 1 multiplied by equation 2. So we will write sin I upon sin R into sin R upon sin E equals to ANG into GNA. Okay. Now sin R and sin R, this will cancel, and sin I upon sin R equals to ANG, and principle of reversibility says that GNA equals to 1 upon ANG. Okay, so we will put here in place of GNA we will put ANG. So 1 upon ANG. So this will also cancel, and sin I, this is E. So here sin E, sin I upon sin E equals to, this will be equals to 1. So here we see that sin I equals to sin E. So we can say angle I equals to angle E. Now from the figure, if angle I and angle E are equal, then we can say that the incident ray and emergent ray both are parallel to each other. Okay, so this is the path of incident ray and this is the path of emergent ray, and the perpendicular distance between these two parallel lines is called lateral displacement. Lateral displacement. Okay, so this perpendicular line, this perpendicular distance is called lateral displacement, and here we have proved that the angle of incidence and angle of emergence both are equal to each other for a rectangular glass slab. Okay, so this is sufficient for today, and in the next lecture we will discuss the refraction through lenses. Okay, so keep studying. Thanks to all of you. Thank you.